let's figure out the mass of two objects. So let's say the mass of two objects that are one object that is, so the mass of 1 equals some number, but the mass of 2 is twice that of m1. Okay, so m2 is twice as massive as m2 or m1. What's going on there? Okay, better. Let's say they are orbiting each other, or they are separated by 5 meters. And the acceleration of A1 is 1 meter per second squared. Let's see if we can't figure out what the mass of these two objects is. Okay, so our equation for universal gravitation is g m1 m2 over r squared equals our force. Okay. We also know that force is equal to mass times acceleration. And if we and now if we know we can sub this f up here for this f, we can rewrite our equation as g m1 m2 over r2 equals let's go ahead and use m1 just because it's easier. m1 a1. And actually we should use m1 because we have an acceleration for that. Let's plug in all our numbers, but first we can cancel out one of these m1s. Okay? And we have g m2 over r squared equals our acceleration. Right? Now we can plug in all our answers. So this is 6.674 times 10 to the negative 11 multiplied by m2 is actually just 2 times m1, and our r is 5 meters. So multiplied by, or divided by 5 squared, and our acceleration is equal to 1 meter per second squared. So if we divide both sides by this and multiply both sides by that, let's see what we end up getting. Okay, so we're going to go ahead and do our math. 1 multiplied by 5 squared, or 25, equals 25, divided by our big G, 6.674 to the negative 11. And since we have this extra 2 here, we divide both sides by 2. Okay, I should have thought through my numbers better. M1 is equal to 187.293976626 kilograms. Okay, I made my numbers too big. M2 being twice that, or 374587953 kilograms. Okay, there you go. Well, that was all there was to the first one. Okay, it's pretty straightforward. Do 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 do. Okay, so let's take a look real quick, close up.